everybody, welcome back. This is Unit 9, Lesson 4, and today in class we talked a little bit of how to use reference table F, and we're going to continue with that discussion tomorrow. But for tonight, and this is table F here, but for tonight I'd like to talk about how to use the other reference table related to solubility, which is reference table G, as in George, okay? And this here is what table G looks like. Okay? And what table G shows us is the amount of solute, right? The number of grams of solute. And notice it has a bunch of different solutes, right? Like Ki and NaNO3, those are all your solutes. All of these are solutes. So it tells us the maximum number of grams. It's always the maximum number of grams of each solute that we can dissolve in 100 grams of water, because obviously the more water you have, the more you can dissolve at a bunch of different temperatures. So it really tells us how much we need of each salt to make a saturated solution. Remember, the maximum number of grams is what we need to saturate or make a saturated. SOLN is the abbreviation for solution, okay? So each line on this table represents the maximum number of grams that can be dissolved in 100 grams of water at a bunch of different temperatures, right? From 0 degrees of water, 0 degrees Celsius, to 100 degrees Celsius of our water, okay? So since the line represents saturation, if you have dissolved less than you possibly can, so let's say we're at 20 degrees. Let's say at 20 degrees, and we go up till we hit the line right here for NaNO3. At 20 degrees, we can dissolve maximum. What would you say that is? About 89? 89 grams of NaNO3, but that's in 100 grams of water. That point right there, that's a saturated solution. But let's say at home you made a solution and you only dissolve 60 grams. Let's say you're here, okay? Let's say you've only dissolved 60 grams. You're below the line for NaNO3 at that temperature. That's saturated. You've only dissolved 60. We would say if you're below the line, you've dissolved less than you can, right? And your substance is unsaturated. Because the line is how much you can, right? The line is saturated. And you haven't even reached the line yet. In fact, if you've dissolved 60 and you want to make a saturated solution, this is how much more you'd have to put in, right? You'd have to put in 29 more to be saturated. Right? But what if you heated it up and then cooled it slowly? Let's say, for the same substance, let's say this time you dissolved 100. Okay? You're here. Let's say you've dissolved 100. Well, 89 is saturated. So if you dissolved 100 of the NaNO3, at this temperature, 20 degrees Celsius, then you are above the line. You've dissolved more than what you can. And if you've dissolved more than what you can, if you're above the line, that means you dissolved more. And yesterday in our quiz, we called you, if you dissolved more than is possible, Supersaturated. And remember, supersaturated solutions are incredibly unstable. So if you disturb that at all, right, you're only supposed to be able to dissolve 89. If you disturb that, this much precipitates out. All the extra you're not supposed to be able to dissolve. So about 11 grams would precipitate out if I disrupted this solution. So this graph can be used to tell us how much you need to make a saturated solution at each temperature, how much more you would have to put into saturated, or how much might fall out if you had a supersaturated solution. Okay, so let's take a look at this example that I have here. Let me erase all of my things. It says, imagine, and I'm not sure you have this in your notes, so you may have to just look up here. Imagine you created a solution of KNO3 by dissolving 15 grams of it in 100 grams of water at 25 degrees Celsius. How would you describe the solution? Okay, so we're at 25 degrees Celsius. That's where we are, right? Which is right here-ish. And we've dissolved 15 grams, which puts us right here on the curve. Okay, 15 grams of solute in 100 grams of water. The 100 grams of water just means we can look directly on this graph. We don't need to get that in terms of 100 grams. We're good to go. So if it's 100 grams of water, you can pretty much ignore that. That just means look directly at the curve. All right, now our substance is KNO3. So what can be tricky, oops, I'm sorry. Okay, I'm still going, sorry about that. What can be tricky is the names of these things. So KNO3 is right here. Make sure you're looking at this line on your curve. Okay? So at 25 degrees, to be saturated, I would need about 40, right? I've only dissolved 15 grams. See how my point falls below the line? So I would describe this solution as unsaturated, because I haven't dissolved as much as I possibly can. All right, here's another example. How many grams of NaNO3 would have to be added to 100 grams of water? Again, remember, if you see 100 grams of water, that just means you can use the chart as is. At 45 degrees to make a saturated solution. So this is a pretty straightforward question. You go to 45 and you go up to NaNO3. Whoops. Yeah, if you draw a straight line, it's a lot easier. NaNO3. And how many grams would need to be saturated? You go till you hit the line. That's about 110 grams is the maximum amount you can dissolve. Okay, according to table G, which solution is saturated at 30? Okay, so the first one says 12 grams and 100 grams of water. Good, I can use the curve as is. So 30 degrees, 12 grams. That's about right here of the KClO3. That's on the line. That's saturated. There we go, because it falls on the line. For the record, for this one, choice 2, do you see how it says 200 grams of water? That's not going to work, because our chart is only in 100 grams of water. So if you have 12 in 200, that would be what in 100? Because we need our chart in terms of 100 grams of water. So that's really 6 grams in 100, right? So that's really the same as saying 6 out of 100 grams of water. So then we could use the chart. And you'll see if you're at 30 and you only dissolve 6, you're unsaturated. You didn't hit the line yet for the KClO3. If we just check the other choices just for fun, for the NaCl, 30 grams of NaCl and 100 grams of water. Again, 100 grams, I can look right on the chart, and we're at 30 degrees. 30, 30. Where's the line for NaCl? Right here. Our point is under the line. We haven't reached the line yet. We're unsaturated. We haven't dissolved as much as we can, because at 30 degrees, we should be able to dissolve 38. That's saturated. we've only dissolved 30. So we're unsaturated. And then the final choice, notice it's 200 grams of water. So we need to get that in terms of 100 grams so we can use our chart. So if it's 30 out of 200, it would really be 15 out of 100, right? So 30 and 15, again, we're under our line. This is also unsaturated. Okay? So that's one of the tricks that they do is they give you different amounts of water rather than 100 grams. All right. Let's look at number 3. 100 grams of water, that's good, I can use the chart as is saturated with NH4Cl at 50 degrees. Let's see how much that is. 50 degrees, NH4Cl. What is that? Right there. That's about 52 grams, would you say? According to table G, if we lower the temperature to 10, how much will precipitate? So if we go to 10 and our NH4Cl line, we can only dissolve 32 grams. So that the difference falls out of solution. So you subtract those. And what would you get? About 20 grams will precipitate out. Because you have 52 in, and then you can only have 32 in. So the difference between those lines is what precipitates out of solution. All right, I'm going to do number 4, and then you can do number 5 for class tomorrow. According to table G, which of the following saturated solutions is the most concentrated? That means it has the most stuff dissolved. Okay, so let's see. Ki at 0. 0, oh boy, where's that? Ki. Wow, that's pretty high. It's all the way up here. 0 Ki. What's that, about 128 grams? That's a lot of stuff. It's a lot of solute. Okay, KNO3 at 70. 70 KNO3. Whew, that's even more. What would we say? That's about 138, maybe? 136, 7? I'll see. Looks like more. I'm going to say 138. That's an 8, everybody. NH3 at 100. Loser. You can only dissolve about 8 grams of that. It's not very soluble at 100 degrees. And KClO3 at 10. 10 and KClO3. It's about right here. I don't know, what are we saying? Maybe like 7 grams there. So the most concentrated has the most stuff dissolved. That would be your KNO3 because you had 138. So for class tomorrow, I want you to do this. Come in with the right answer. And that's it for tonight, everybody. We'll do more practice with table F and table G tomorrow, which is Friday. Woohoo! Have a good night. Bye-bye now.